Sample problem 4.04, a projectile dropped from airplane. In the given figure, a rescue plane flies at 198 km per hour, which is equal to 55 meter per second, and constant height h equal to 500 meter toward a point directly over a victim where a rescue capsule is to land. So we figure. So what is given in the figure? A rescue plane is going to give the rescue capsule near to this victim. And here the pilot has to land this capsule near to this guy. So for that, we need the angle. And the flight is exactly at this constant height h equal to 500 meter. And also the flight initial speed v0 equal to 55 meter per second. So here the rescue capsule is our projectile. So for that, we have to launch this projectile near to the victim to save him. So for this, what we have to find in the first question, what should be the angle phi of the pilot's line of sight to the victim when the capsule release is made? That means we have to find the angle phi. And in the second question, as the capsule reaches the water, what is its velocity v vector? That means we have to find the v vector here. So two answers we have to find. The first one is angle phi and the second one is velocity v vector. So first of all, better we can write the given first. By that, things will be easy for us. So what is given in the question? The rescue plane initial speed is given, which is v0 value. So here I'm going to answer for the first question. So v0 value here is 55 meter per second. And the flight is at the constant height h equal to 500 meter. And also the second thing, you have to see the figure. The flight having the same speed and it is moving the same direction. That means with respect to the axis, its angle is 0, right? So that means here the flight angle, that means the theta value. So don't consider this theta. I'm talking about the direction of the flight. So that angle I'm talking. So that means here for this angle theta, because the flight initial speed is in the same direction towards the x. So with respect to x, what's the angle? The angle which the rescue plane made here is a 0 degree. Clear? The angle what I am just wrote here is not this angle. I'm talking about with respect to the x-axis, the rescue plane angle is 0 degree. Understand? So now what we are going to do for finding the phi, that means the angle, that is our line of sight. So if you want to find the angle phi, we already studied in chapter number 4 in projectile motion, not chapter number 3. Vector itself we studied, right? So we studied the formula phi, which is equal to a tan inverse of a y component divided by x component. This is the formula. So here, what is our y component? So you have to see the figure. This angle we are going to find. That means closer to the angle, we have the cosine theta. That means this distance, that means from here to here. So what is the distance? So the distance here is nothing but h, and that is our x component. Clear? And then from this point to the victim, this is our y component. So let's take this distance is x. So when you substitute these values here, so what you will get? So this is our y component. Am I right? So when you substitute this value in this formula, we will get the angle phi, which is equal to the tan inverse. What is our y component? Our y component here is x and our x component here is h. So that means x over h is the formula we are going to use for finding the answer for phi. Clear? And h value already they gave in the question, which is 500 meter, and the x value we are going to find. Clear? Okay, so first of all, what I'm going to do, first I'm going to write the two equation. Which equation? In chapter number 4, when we studied the projectile motion, we studied two equations for finding the position in x as well as y axis. So what's the formula for x? X, which is equal to v0 cosine theta multiplied by t. Likewise for y-axis, y equal to v naught sine theta multiplied by t minus half gt square. If you are getting confused about this angle, let's we take this angle is theta naught. So that means this is theta naught, this is theta naught. Clear? Because why I just wrote theta naught? Because we have the another angle theta here. So we have to avoid the confusion. So let's we take this angle is theta naught. Now what I'm going to do, we have to see the angle for phi. We have to find the value of x. So for finding the value of x, I have to use this equation for getting the answer for x. But for that, what we need the time. So what I'm going to do, first I'm going to use the equation, that means the position with respect to y-axis, and by using these I'm going to find the time, and once we find the time, I'm going to substitute the time here to get the answer for x. Then only we can find the line of sight angle phi. So let's we substitute the value here. You can see the y axis. So that means from the flight to this guy, and they clearly mention the axis of the airplane. This is a x-axis, this is the positive of y-axis. That means below to this aeroplane, this is our negative y-axis. Am I right? So that means we have to consider here as a minus 500. So why we put minus 500? Because from the aeroplane to the surface of the water, they clearly mentioned the h is 500, but we have to consider the x-axis and the y-axis here. So here, with respect to x-axis and y-axis, the upside is the positive y-axis and the downside is the negative y-axis. So we have to consider from the aeroplane to the surface of the water, we have to consider the value of h is 500 for this calculation. That's the reason I put 500 here. And also we have the initial speed, which is a 55 meter per second. That is the aeroplane initial speed. So 55 meter per second multiplied by a sine of 0 degree multiplied by a t minus half, and g value is 9.8, and here t square. Now sine of 0 degree is 0, so anything multiplied by 0 is 0, so totally this term will be discarded. So what is remaining? We have minus 500, which is equal to minus. So when you divide this 9.8 divide by 2, what we will get? We will get the answer of, I think, 4.9, right? So 9.8 divided by 2, what we got? We got the answer as 4.9. So 9.8 divided by 2, I'm going to write here as minus 4.9 t square. So now I'm going to find the value of t. So for that, I have to take this minus 4.9 to the left hand side of the denominator. By that, what we will get? Minus 500 divided by minus 4.9, which is equal to t square, right? So let's find, and negative get cancelled with this negative. So 500 divided by 4.9, I got the answer here as 102.0. So t square value I got here as t square value here is 102.04. So I have to take the square root on both sides. By that we will get the answer for t. So if you take square root on both sides, what we will get? I got the answer here as 10.10. Therefore t equal to 10.10 second. So this is the answer for the time. Now what I'm going to do, for finding the value of x, I'm going to take the t and I'm going to substitute the value here. So once we substitute the value here, we will get the answer for x here. So therefore x equal to, your initial speed of the aeroplane is 55 meter per second, and cosine of theta naught here is 0 degree, and the time value here is, we got as 10.10. So multiply 10.10. So cosine of 0, the maximum value here is 1. So 55, x equal to 55 multiplied by 10.10. So 55 multiplied 10.10 is the value of 555.5. So x here is equal to 555.5, and unit here is meter. So now we can easily find the angle of sight phi, because h value already they gave has 500 here. and the x value we got here as 555.5. So once you substitute the value of x here, we will get the answer. So now we are going to find the answer for the first part. So angle phi, which is equal to a tan inverse of x divided by h. So here x value I am going to substitute here, and h value here is 500. So phi, which is equal to a tan inverse of 555.5 divided by 500. So let's see what's the answer. So tan inverse of 555.5 divided by 500, I got the answer here as 48. So what's the angle here? Of 48 degree. So this is the answer for the first question. That means let's we go back to the figure. So in the figure, what's the angle? Here we find the angle here as 48 degree. Now in the second part, we have to find the value of the speed, right? So for this, I have to use the speed in both x-axis and y-axis. By that, you can easily find the answer for the B part. So in the B part, what we have to do, we have to use the equation of the speed in x as well as y. So what's the equation for V of x? V of x in chapter number 4 we studied V of x formula and V of y formula. V of x formula is V naught cosine theta naught, right? And V of y, which is equal to V naught sine theta naught minus gt. So this is the speed in x and speed in y. Clear? Now I am going to substitute the value. By that we can easily find the velocity vector. So if you substitute v of x, which is equal to v naught, that is initial speed of the airplane, is 55 meter per second, a cosine of 0 degree. By that we will get the answer here, v of x, which is equal to 55 meter per second. Likewise, when you substitute the value for v of y, what you will get? V naught value is 55, a sine of 0 degree minus 9.8, and the time value we have to go back because we already got the time value here is 10.10. So I have to use this value here. So 9.8 multiply 10.10, and here sine of 0 is 0. So anything multiplied by 0. So by that this term will be gone. So what is remaining? V of y, which is equal to, we will get the answer here as minus 9.8 multiplied by 10.10. We got the answer here as minus 98.98, minus 98.98 meter per second. When we frame the velocity vector equation, therefore the velocity vector equation is given by the x component with y component. That means v of x I cap plus v of y j cap. So now what I have to do, I have to substitute the value of v of x here, I have to substitute the v of y here. So by that we will get the velocity vector. So we have to substitute the value. So 55 meter per second I cap minus, because the value of y of v of y is minus, so minus 98.98 meter per second j caps. Now by using this, we are going to find the angle theta. So here, if you need the magnitude, we can find, because they did not ask the magnitude in the question, they asked only the angle theta. So you can go back to the figure. They ask you to find only the angle of the velocity vector theta. If you want to find the magnitude, no problem, we can find, because we already know the rule. So what's the formula for velocity magnitude? So velocity magnitude, which is given by square root of the x component square. This is your y component. So 55 square plus minus 98.98 square. So let's see what's the answer. So square root of 55 square plus minus 98.98 square, 98.98 square. I got the answer here as 113.23. So 113.23. The unit is meter per second, but we have to find only the velocity vector. So let's just find the answer for the velocity angle. So theta, which is equal to tan inverse of y component divided by x component. Your y component here is a tan inverse of y component here is minus 98.98 divided by 55. So by that we will get the answer for the velocity vector. So tan inverse minus 98.98 divided by 55. Here we got the answer as minus 60.94, minus 60.94 degree, and this is the angle for the velocity vector. That means we have to go back to the figure. So what's the angle for the theta here? The angle for the theta here is minus 60.94 degree. So this is the answer for the second question. I hope you understand this and the procedure, the steps for these two questions. So in this way you have to solve. Thank you.